Well, hello there and welcome to Irish Astronomy Week 2025. I'm Paul Evans and I'm going to talk you through some of the things that we're doing, starting off with a look at the history of the 20th and 21st centuries in Irish astronomy. Ireland has played a significant role in astronomy, particularly in the 19th century, with the famous Leviathan telescope at Birr Castle. However, the 20th and 21st centuries saw a shift from individual observatories to institutional and international collaborations. The early 20th century was a quieter period for Irish astronomy. However, Irish astronomers contributed to astrophysical research through university-led programmes. One key institution was Dunsink Observatory, which became part of the Dublin Institute for Advanced Studies, that's DIAS, in 1947. Dunsink was instrumental in celestial mechanics research, particularly under Hendrik van der Holst and Padraig O'Siochin. Ireland also contributed to radio astronomy. In the 1960s, researchers at NUI Galway, then University College Galway, were involved in studying the Sun's radio emissions. Meanwhile, Irish astronomers collaborated with European and American institutions in theoretical astrophysics, focusing on topics like stellar evolution and quasars. The 21st century saw Ireland deepen its international engagement in astronomy. A major milestone came in 2018, when Ireland joined the European Southern Observatory, ESO, giving Irish researchers access to world-class telescopes like the Very Large Telescope, VLT, in Chile. Ireland also became involved in space-based astronomy through participation in the European Space Agency, ESA. Irish scientists contributed to missions such as Gaia, which is mapping the Milky Way, and the James Webb Space Telescope, JWST. Research expanded into exoplanets, black holes and cosmology, with institutions like Trinity College Dublin, University College Dublin, Queen's University Belfast and NUI Galway leading projects in these fields. Another significant development was the establishment of the Irish Low Frequency Array, ILOFAR, in 2017 at Birr Castle. This radio telescope is part of a Europe-wide network studying cosmic, radio waves, pulsars and deep space phenomena. ILOFAR revived Birr's historic role in astronomy, making it a hub for 21st century radio astronomy research. Looking ahead, Irish astronomy continues to grow with an increasing focus on space exploration, astrophysics and public engagement. The Irish government's support for STEM education and international research collaborations ensure that Ireland remains a key player in global astronomy. From early telescope innovations to cutting-edge space research, Ireland's role in astronomy has evolved significantly, demonstrating a strong commitment to exploring the universe. Okay, so let's have a look at the night sky. I've got the controls here set to 7:30 in the evening on the 2nd of March. That's the Sunday of Irish Astronomy Week. And we'll sort of look to the west just after the sunset, and we should still be able to see Venus for a while. Now, Venus is very bright at the minute. It's also coming to that point where it comes sort of between the Earth and the Sun, and we notice that when we actually look at the shape of Venus. We'll zoom in on this, and we'll see that Venus is actually a very thin crescent, and it's actually almost 1 degree in diameter. Making it 1/30th of the diameter of the Moon, which we'll look at in a moment, and is that crescent shape, so it's only 11% illuminated at this stage, and will soon disappear into the sunset and reappear out the other side as a morning star in the morning sky, but by the end of March actually. So that's Venus being a crescent. And we'll come back up and we'll go and have a look at the Moon, because we'll find that the Moon is a very, very similar shape, just about 30 times bigger. There we are, that's the Moon. Thin crescent, that's the sun illuminated side of the Moon, and this is showing here a little bit of Earth shine, and sometimes you can see that. Depends how cloudy the Earth is, funny enough, as to how much light is reflected back to the Moon. Sunlight reflected from the Earth back to the Moon that illuminates the dark side of the Moon. Now looking perhaps round to the south in the sky, and we see the familiar shape of Orion. And Orion is a fantastic constellation. You can use it as a signpost to get to very many other places. It has the belt here, Betelgeuse, the red giant star up the top there, and the blue giant star Rigel. Similar brightness, those two stars. Betelgeuse is much more variable, and indeed in recent years has been going up and down quite a bit. Betelgeuse is probably about the best candidate in the sky for a supermarket, and supernova. Betelgeuse is probably the best candidate in the sky to go supernova, which means that the star could actually implode, because what happens is that the energy stops being produced and everything just collapses under gravity, and when it all gets crushed together there is an almighty bang. And Betelgeuse, when it does go supernova, which might be this year and it might be in a million years, somewhere in between, it will be visible in the daylight. It would be about the same brightness as a full moon. Okay, there's the other areas that we need to just look at in Orion while we're here. Orion's sword is always worth a good look. There's Messier 42, the Great Orion Nebula, and just above that the Running Man Nebula. And also, if we move over towards the star Alnitak in the middle, it's the lower one of Orion's belt, and we see to the left of that telescope, or actually cameras will show this quite well, the Flame Nebula, and also below that the famous Horsehead Nebula. That's all in Orion. One of my actually favourite objects in the sky these days, if you have one of the sea star things, it makes a great job of it. To the left of Orion over here is this wonderful nebula called the Rosette Nebula, and that's looking in on the Rosette there. It has a star cluster at its centre, and then lots of hydrogen alpha red nebulosity around it. So that's that, the Rosette. So what else have we got here? We've still got some of the planets visible, apart from Venus that we looked at. Jupiter is up in Taurus, just above Aldebaran and the Hyades. It's Aldebaran there and the Hyades star cluster around it. And Jupiter, of course, you can actually look at and see the 4 Galilean moons. And if you follow them from night to night, you'll see that they are obviously revolving around Jupiter. We've got Europa, Io, Callisto, Ganymede there. If you look at the next day, you'll find that they've moved. And there's no great red spot at that particular time. This is 7:30 on the 2nd of March. But you can, about half the time, you can see the great red spot. Jupiter rotates very fast in about 10.5 hours. You will, if you watch it long enough, see the great red spot come past. And that is a storm that's been raging for about 300 years. So what else have we got in that area of the sky? Let's have a look. We have Orion. Now, you can use Orion as a signpost, and if you take the belt of Orion, follow those 3 stars down, you'll come to a very bright star, indeed the brightest star in the sky. That's not a planet or a space station. And that is Sirius. It's bright really because it's not very far away. It's only 8 light years away. It is a double star, and if I zoom in a lot, we can see there are Canis Major B is the white dwarf that accompanies Sirius. It wouldn't be that difficult to see were it not for the fact that it's got a very bright Sirius right next to it. But it is actually quite hard to see, and wasn't actually seen until 1861. Although certain tribes in Africa are alleged to have had knowledge of it before that, which is a very puzzling situation. But there's Sirius, brightest star in the sky. And we'll zoom out from Canis Major there. We also have Procyon, which is quite bright because it's quite nearby as well. And then up in Gemini we have the 2 twins, Castor and Pollux. And in Gemini at the minute is the planet Mars. Let's have a look. And it's pretty bright still in Mars, because it's quite close to the Earth, just the way that these things happen. But even when it's close to the Earth, Mars, I have to say, is a bit unspectacular, even a small telescope. And it's very, very hard to see the 2 moons of Mars, Phobos and Deimos there, because they are about 12 magnitude, and they are next to another bright object, and so they're quite hard to see. But some people have done it. I haven't, but that's my Still on my bucket list. So, what else have we got here? You can see, now it's more of a sort of a spring thing, but in the beginning of March we start to see Leo coming up in the evening, and he will get quite high in the evening. Leo, it's one of those constellations that does look a bit like what it's supposed to be. It's you can see the sort of backwards question mark at the front of it, that with the bright star Regulus at the bottom, and that, you can say that, yeah, that looks like a lion's head and a lion's body and a lion's hind legs there. There's a good few interesting things in Leo, not least there's a nice cluster of galaxies down near the hind legs here, and we'll zoom into those and have a closer look, if I can find them. Oh, here they are, yes, the Leo triplet over here. We have 3 galaxies nicely arranged. That will fit, if you've got a C star, that will fit in the C star frame, all 3 galaxies. So you have that one there, and the 2 spiral galaxies behind, and that is the Leo triplet in Leo. So have a look out for that if you've got your C star, and I can't recommend the C star highly enough. It's an amazing piece of equipment. Everyone should have one if they're into their astronomy. And that's pretty much a look round the southern part of the sky. We have of course the Plough, Ursa Major up in the north here. The Handle and the Dipper part of it. I like the American name Big Dipper. Ursa Major is a bigger thing, it's the whole constellation there, but the Plough or Big Dipper, and the most important thing about this is it gives us the pointer to north. So you take the 2 end stars of the Dipper there, and you go 5 times the distance between them following the line up, and you will come to the pole star. And that's Polaris, the pole star there, which I'll centre up here. And just show you something important about Polaris. If you're aligning an equatorial mount or something like that, that's the first place you point your finder is to Polaris. But I'll just show you something here. It's not quite perfectly in the right place. Sorry, that's the wrong button. Here we are. There. Now, I've put the equatorial grid on, and you see that Polaris is not quite at the North Celestial Pole. It's actually about 3/4 of a degree off it, so really, if you want to accurately align an equatorial mount for photography, then that's what you'll do. Is you'll do that extra little movement to make sure you're pointing at the North Celestial Pole, not just straight at Polaris. So that's Polaris and the North Pole. We can also come round and we can see at this time of year we can find the Andromeda Galaxy. We come back to Venus and the Moon where we were, and not far from that is the Great Square of Pegasus, setting at this point actually. So you have to do it early in the evening. But if you take the 2 top stars of the Great Square, put that distance in your head, come up to this one here, and take a slight right turn, and go the same distance again, you will come to a star called Merak here. And if you stop at Merak, take a sharp right turn, 90 degrees, go a short way to a less bright star, that is Mu Andromedae, and go the same distance again, and you will find a little dim patch, fuzzy patch there, and that is the Andromeda Galaxy M31, and its companions M32 there and M110 there, and that is light from over 2 million years ago. So there's no proof it's really there. It probably is. It's probably moved a bit and changed a bit, but that is 2 million year old light, or 2.5 million year old light, just by virtue of the distance that light has had to travel. That's how long it takes. So that's a quick scoop round the March sky. I hope you'll get the chance to see it sometime during the week and have a good look around. It's a great sky. I'm going to talk about something else now. I'm going to talk about the Aurora Borealis, or Northern Lights, because March is a very good time to be seeing those as well. So we'll just go into a little piece about that. The aurora borealis, or northern lights, is a breathtaking natural phenomenon caused by charged particles from the sun interacting with the Earth's magnetic field. While it is most commonly seen in high-latitude regions like Norway, Iceland and Canada, it is occasionally visible from Ireland, especially during periods of strong solar activity. In Ireland, the best chances of witnessing the northern lights occur in the northern and western coastal regions where light pollution is minimal. Counties such as Donegal, Mayo and parts of Northern Ireland, including Antrim, offer some of the best viewpoints. Clear, dark skies and geomagnetic storms increase the likelihood of a sighting, especially during autumn and winter. The aurora appears as dancing ribbons of green, pink and purple hues, creating an ethereal glow across the night sky. Many Irish observers use aurora forecast apps to track solar activity and improve their chances of catching this rare display. This year is expected to be the peak of solar cycle 25, and there have been some memorable displays of the lights in the last couple of years. The Aurora Watch UK phone app and the IAA website page irishastro.org/aurora-current-conditions, all lowercase, both have up-to-date real-time data on conditions, and spaceweather.com gives a worldwide overview. Enjoy the lights. Once you've seen them, you'll be back for more, and your smartphone will capture the colours. So that's some of the highlights of Irish Astronomy Week 2025. Keep up to date on the website, irishastronomyweek.ie. And apart from that, keep safe and keep looking up.